Discussion now. Conformal transformation. Conformal transformation. First we are going to discuss the transformation. Discuss W is equal to Z square. The transformation of W is equal to Z square we are going to discuss now. So first we have to consider that W is equal to Z square. Consider W is equal to Z square. Now we have to convert W plane, Z plane, the image in the Z plane to the image in the W plane. So for that we have to substitute for Z either in the form of Cartesian or in the form of polar. So first I am going to substitute that. Let Z is equal to, as we know that W is equal to U plus IV. W is equal to U plus IV, and I am going to substitute Z is equal to X plus IY. Z is equal to X plus IY. So we obtain the transformation, the discussion become W is U plus IV. U plus IV is equal to X plus IY whole square. X plus IY whole square. Now U plus IV is equal to, here I am using A plus B whole square formula. A square plus B square plus 2AB 2IXY. So as we know that I square is nothing but minus 1, x square minus y square plus I into 2xy. Now separating the real and imaginary terms. We obtained U is equal to x square minus y square and v is equal to 2xy. So this is what we got. Okay, now we have to consider the cases. To consider the curve in the Z plane and to obtain the image in the W plane. Okay, so now I will go for case 1. In case 1, I will consider that x equal to c1. Let x equal to c1. As we know that x equal to c1 is a straight line parallel to y-axis. So if you consider this as a x-axis, this is y-axis. Okay, I consider that x equal to c1 in the Z plane. X equal to c1 is the Z plane. X equal to c1 is a straight line parallel to y-axis. Now we are going to find what is the image in the W plane for the straight line parallel to y-axis. Okay, right. So where we can substitute x equal to c1. So in both these equations. So we have to substitute x equal to c1 in these two equations. So u is equal to c1 square minus y square and v is equal to 2c1 into y. So here you find y, then substitute y, then you will get the curve completely in terms of u and v. So we have to eliminate x and y. So y is equal to v by 2c1. So now substitute v by 2c1 here. So we obtain u is equal to c1 square minus v by 2c1 whole square. Okay, you take this to the LHS and u to the RHS. So we obtain v square divided by 4 into c1 square is equal to c1 square minus u. So this is what we got. Right? So next we have to simplify this. V square is equal to 4 c1 square into c1 square minus u we got. Okay, I will take minus common. I will tell you why I am taking minus common. If you take minus common in the RHS, it becomes 4c1 square into u minus c1 square. It is looks like y square is equal to 4a into x minus h. So this is represent a parabola, right? This represents what? Parabola. This represents the parabola in the W plane, symmetric about the real axis. Real axis means u axis. with its vertices. So this represents this represents parabola parabola symmetric about symmetric about symmetric about u axis, that is real axis, u axis with vertex at with vertex at c1 square comma 0 and focus at the origin and focus at the origin okay, and it is in the w plane So this is what we got. We consider a straight line parallel to y-axis and we got its image in the w plane as a parabola symmetric about u-axis with the vertices c1 square comma 0. So if we consider the line, it may be observed that it may be observed that if we consider x equal to minus c1 also. So minus x equal to minus c1 means here we will get here. So here this is a line x equal to minus c1. So we have to find the image of this in the w plane. So here we have to replace x by minus c1. Minus c1 whole square is c1 itself and here it become minus c1. So we have to find out here it become minus c1. Y is equal to minus 2. V by minus 2 c1 we got. So here we have to substitute y square. Y square become v by minus 2 c1 whole square. Minus 2 c1 whole square means what? So here you will get minus. So minus 2 c1 whole square is plus 4 c1 square itself. So for that now x equal to minus c1 is also transformed. We will not get any change. Also transformed into the same parabola. Same parabola. I will write that parabola in the end, or you can write here itself. Parabola symmetric about u-axis with the vertices c1 square comma 0. This is a parabola symmetric about u-axis. This is u-axis and this is v-axis, real axis in the w plane with the vertices c1 square comma 0. Okay. Next I will go for case 2. So now I will consider let y is equal to c2. Y equal to c2. If you draw the line y equal to c2, so where you will get y equal to c2? This is a line y is equal to c2 which is parallel to x-axis. Now we are going to find the image of this line in the w plane. Okay, here we have to substitute. The value for y equal to c2 and here also y equal to c2. So therefore this I will call it a system of equations 1. Now I will substitute in equation 1 u is equal to x minus c2 square and v is equal to 2x c2. From this you find out the value for x is equal to v by 2c2. So here you substitute the value of x. Therefore it become u is equal to what is x? V by 2c2 minus c2 square. Okay, sorry, x square here we have. It is x square. So this is whole square. Okay, now simplification of this. You take c2 square to the LHS. It become v square by 4c2 square is equal to u plus c2 square. This is what we got. Is it clear? So now from this v square is equal to 4c2 square into u plus c2 square. So this is like y square is equal to 4a into x plus h. This represents this represents again a parabola symmetric about u axis only, symmetric about u axis with vertex minus, it is x minus h should be there instead of x minus h, that is minus c2 square will be there, minus c2 square comma 0, and focus at origin, and focus at origin, focus at origin. Okay, next I will consider, so it may be observed that it may be observed that so y is equal to minus c2. So if you take y equal to minus c2, so here you will get minus 2x c2, here you will get minus, so if you square it become plus, no change, right? So here minus c2 whole square is plus c2, no change in the final equation after substituting y equal to minus c2. Okay, it may be observed that y equal to minus c2 is also transformed transform to same parabola. So that means here we got the parabola symmetric about u axis, but at the vertex is minus c2 square comma 0. Okay, for that I am writing the parabola like this. Okay, this is a parabola symmetric about u axis only, but with the vertex minus c2 square comma 0. So, and one more straight line we consider, that is y is equal to minus c2 also. This also map to the same parabola. Transformation is nothing but mapping. So finally, what we are observing and conclude here is that the straight line parallel to the coordinate axis are mapped to the parabola symmetric about u axis in the w plane. That is our conclusion what we have. Okay. So next we go for case 3. What is the case 3? So as I told you that we can substitute z either in the form of Cartesian or in the form of polar. So now I am going to consider in the Cartesian form, here I consider the Cartesian form. Next I will consider the polar form. So let case 2, z is equal to, I will take r e power I theta. Now the transformation become w is equal to z is r e power I theta whole square it become. So now it is r square e power I theta whole square. So which is equal to r square e power I 2 theta. So I will take this as capital R e to the power of I into 5. So actually as we know that r e power I theta represent a circle, with center at origin and radius r. Okay, this in the z plane, it maps to a circle with center at origin only, but with the radius capital R, and angle is 2 theta, that is phi. Here angle is phi, here angle is theta. Okay, so this is z plane, we consider a circle, and we got a circle in the w plane also, but with the radius r square, and the angle is 2 theta. Okay, here uh, we considered the straight lines parallel to the axis, x-axis and y-axis. We got the parabola in the w plane image. The image of the straight line parallel to the x-axis and y-axis. We got the parabolas in the w plane. Okay. So this is the discussion about W is equal to Z square, conformal transformation. Why it is conformal transformation? Because the angle is preserved. So here what we consider the images in the Z plane, what we consider the images in the Z plane, one we consider the straight lines parallel to the y-axis as well as straight lines parallel to the x-axis we considered. So the angle between the straight lines parallel to y-axis and the x-axis is 90 degree. What we got the image? What we got the image of both the straight lines parallel to x-axis and y-axis. That parabolas, if you measure the angle between that parabolas, so we have to draw the tangents to that, then measure the angle between those two tangents, that will be 90 degree. So the angle is preserved between the curve and the image of that curve. So therefore the transformation W is equal to Z square is conformal transformation.